Guys, today we are going to talk about variable linear voltage regulator. Why is it called variable? Because we are going to vary and adjust the output voltage. Okay, so the IC we are going to use is LM317 IC. LM317 IC. So this is the IC we use in a variable linear voltage regulator. So guys, let's discuss the circuit diagram. So this is the actual component. It has 3 pin, pin 1, pin 2, pin 3. So you can see in the circuit here, I've tried to change, it has changed. So this one is pin 1, pin 2, pin 3. When you use this circuit to build yours, make sure you take care of this. These pins here I've named them. So let's start with the easiest one, so we end up with the complicated one. Let's start with pin 3. So when you want to connect this, you see, let me plug it in this breadboard here. So you can see here is pin 1, pin 2, pin 3. When this IC is facing you, so this pin 3 is here. So pin 3, at pin 3, there is a 330 nanofarad capacitor which is connected between the positive and the ground. Okay, and it is at pin 3 where the input voltage you want to regulate is getting in. It is at pin 3. As you can see here, V input is coming to pin 3. So at pin 3, you connect a 330 nanofarad capacitor. We are done from pin 3. Let's go to pin 2. So pin 3 is here, this one. Pin 2 is in between. So at pin 2, you connect a 1 microfarad capacitor, positive and the ground, as you can see. So it is at pin 2 where you get your output voltage. Pin 2 where you get your output voltage. Then between pin 1 and pin 2, you connect at 270 ohm resistor. So this is pin 1 and pin 2. So you connect at 270 resistor between these two pins. Okay, like I've connected, you can see the resistor is connected between pin 1 and pin 2. And at pin 1, now you will connect a 5K variable resistor. What's a variable resistor? This is a variable resistor. A variable resistor has 3 pins. As you can see here, pin 1, pin 2, pin 3. So pin 1, pin 1, pin 2, pin 3. So when you connect it in the circuit, you can connect it like this. So you can take this one. So you connect one of the pins. You can take the last one here, the third one here. You connect it direct to pin 1. Okay, pin 1, as it is connected, pin 1. So the other 2 is connected to the ground. So that is how you will connect this circuit diagram. Now let's test our circuit diagram. Let's have it here. So I've already built it. It is here. So if you check very well, so as we have explained, it is everything I have done here. So we're going to test and see why this type of voltage regulator is known as a variable voltage regulator. So let's turn it on. So I hope it's already on. So there is where you have to observe. There is somewhere you have to observe. So you can see you observe the meter. You can see the voltage is 1 volt. Then you come to variable resistor. Then you can start vary it slowly by slowly as you observing the meter. You can see the voltage is increasing slowly by slowly, up to the maximum input voltage. So the advantage of this voltage regulator is that it can give you the voltage from 1 point something up to the maximum voltage. Maximum voltage is the voltage you are giving as the input. In our case, we gave 14. So if you vary up to, you will see that the maximum input voltage is 14.11. So when we vary this, you can see that the least voltage is 1.58. So the advantage of this is that you can vary between 1 to maximum voltage. Let's take 5 volt. You can see, yes, we can still use this one. Yes, let's use that one, but that one is 6. Okay, 5.38. Okay, So let's connect an LED and see what will happen. So let's test. Let's start with an LED, which is 5 volt, and we'll test this bulb, which is 12 volt. So let's turn it on first. You can see it is 5 volt. You can see at that point the LED is lighting because that is the maximum voltage for that LED. So let's move the LED so that we don't burn it. Then we vary the voltage up to 12. Let's remove the LED. So let's now vary and connect the bulb. So you can see the voltage is 5. Let's vary up to 12 and see what will happen. So let's go back to 5 where we were. Okay. So now let's vary up to 12 and see what we'll have. You can see the brightness. So that is 12 volt now, which is now lighting it brighter. So this means that this type of power supply, this type of voltage regulator is very, very good and efficient, that it's providing you the voltage from any level you want to use. If you did 9, the input voltage is 14. So any voltage between 14 and 0, you will get it. So if you did 9, you just regulate. Let's regulate up to 9 and see what will happen. So you regulate 9, you can see you can get 9, that is 9 volt. You can get 8, 6, any voltage. So even if you put 40, you will get voltage between 0 to 40. You will just need to regulate and get your output you require. So that is what we have to do about this variable linear regulator. Something very important to understand while using linear voltage regulators, this it dissipates a very large amount of heat because that's how the principle it is designed to function. At a time when it is overheated, it will stop working to cool. After cooling that, it will again switch and come back to function. So for us to be able to deal with that heat, we have two methods we are going to use. You need heat sink. You see this element here, heat sink. This is how you connect that linear voltage regulator. You see I will use that linear wire here because the screw is got lost. So you can see this hole here. This hole is for the screw. Even the voltage regulator are designed to have those holes to allow you to connect the heatsink. So you will connect that screw here. You screw it very well properly. Then you plug it in the circuit or you solder it properly. So the heatsink will allow you to deal with that amount of heat. Or you can also have other cooling systems like a fan. Okay, like a fan, you can add it so that you deal with that heat system, because interrupting the system, switching on and switching off due to temperature rising, that's not good. So this is the way you can deal with that heating effect of the switching linear voltage regulators. Thank you guys.